Evening, everyone. I'll be presenting about maternal morbidity risk across latent maternal profiles and U.S. birth data. Morbidity, the rates of morbidity has been on the decline on a global scale, but within the United States, the rates have been pretty persistent or exceeding that, especially those of other high-income countries. Maternal morbidity is defined as any health condition that causes adverse outcomes during pregnancy, during delivery, or even after childbirth. Some common examples would be hemorrhaging, which is severe bleeding, cardiovascular conditions, hypertensive disorders, and gestational diabetes, just to name a few. And with the rates of morbidity, they are also disproportionate across the population as well, mainly because of race, socioeconomic status, and access to care. And when you think about maternal outcomes as a whole, they are influenced by clinical conditions, reproductive history, behavior, and social and determinants of health as well, which is why I wanted to highlight how maternal morbidity is not necessarily a simple or isolated issue, but it is a complex and multidimensional problem. When I went through a literature review, there were some limitation and gaps in the current approaches as to how maternal morbidity is researched. So even though maternal morbidity is pretty complex, most studies don't really fully capture how the risk behavior actually behaves within a population. So traditional approaches will rely on individual predictors, which overlooks how all of the risk factors interacts together and co-occur. And then when it comes to the statistical models, that results in assuming that there are independent effects across the risk factors, which can oversimplify the complex relationships between them. And with machine learning models, most of the time the studies used um, supervised learning models, which focus primarily on the prediction of an outcome, but it didn't necessarily give any insight into the actual structure of the population itself. And so that leads to maternal populations overall being often treated as homogeneous, which kind of masks any meaningful subgroups or any differences at an individual level as well. And ultimately, what was missing was an approach that captured the multidimensionality of maternal risk overall and how it's structured by combining subgrouping discovery, statistical analysis, and predictive modeling all together into one framework. And I came up with two research questions, as in from leaning from the gaps and limitations in the research. So the first one is, can latent maternal profiles be identified using pre-delivery characteristics and provide meaningful insight into maternal morbidity risk? The second question is, does these profiles stratified modeling improve predictive performance when compared to that of full cohort modeling? And to answer these questions, my study will follow a threefold analytical framework, with the first one being clustering. And this is going to be used to identify any latent maternal profiles within the characteristics and variables that were given to me in my data set. And this will allow me to move beyond isolated predictors and better represent the heterogeneity within the maternal population. And then next will be the statistical modeling, which is going to be used to evaluate how these profiles and some key risk domains I will mention later on in the study are relative to maternal morbidity outcomes. And then finally, with predictive modeling, that will be used to assess whether incorporating these profiles, stratified profiles, will improve the ability to actually identify individuals who are at risk for maternal morbidity outcomes. And together with this framework, it'll integrate the discovery, interpretation, and prediction of maternal morbidity overall to gain a more comprehensive understanding. Now, with my data set, I used a 2024 US birth data set, which included 3.6 million birth records overall, and it comprised of a wide range of maternal characteristics, which you can see with 237 total variables. However, with my study, I only used 38 of the pre-delivery maternal features, which encompass social demographic factors, reproductive history, smoking behavior patterns, prenatal care utilization, comorbidities, and infections. And then with the specific outcomes, these were the outcomes that were specifically laid out in the user guide as maternal morbidity outcomes. And those were maternal transfusion, peritoneal laceration, uterine rupture, unplanned hysterectomies, and ICU admission. And there was a significant class imbalance within this data set where mo- maternal morbidity events only encompass about 1.5% of the data set as a whole. So out of 3.6 million cases, maternal morbidity only showed up in roughly 60,000 total. So because of that, I thought ahead when it came to my statistical analysis and predictive modeling to actually create a composite morbidity outcome to kind of be like a binary indicator to encompass all the presence of all of them overall within each individual birth record. And then with the data pre-processing, I went over the standard processing just to ensure data quality and consistency all throughout. With data cleaning, I removed any irrelevant variables that I did not use. There were some unknown and missing values that were imputed and also converted because some were given miscellaneous values such as U or 99. So those unknown values were um, converted to missing or named values. There was some feature encoding with categorical variables that were binary encoding that were maybe been yes or no to 0 and 1. And then any multi-categorical variables such as race and ethnicity were one hot encoded. And then feature scaling was done just for standardization for the PCA and k-means clustering and ensure equal contributions when it came to the clustering as well. And now we'll get into the first section of the framework with the k-means clustering. And the first step was to perform dimensionality reduction to reduce the feature space, which captured a retained total variance of about 92% with 28 principal components in total. And then to determine the appropriate number of clusters for this data set, the elbow method and silhouette scores were evaluated as you can see here in these plots. The elbow plot and the silhouette scores showed a significant drop after a K value of 4, which shows that any clusters beyond that point would not have a great balance between cluster compactness and separation, which is why 4 clusters was chosen as the number for this study. And then when the K-means clustering was conducted, it provided 4 distinct maternal profiles within the population. And here I have a TS&E projection of those profiles where each specific point on the plot represents an individual and the color is indicative of the profile membership that they belong to. And while the profiles did form some identifiable groupings, there was some overlap between them, which further reflects on the complexity of maternal risk rather than how they have perfectly separated categories in a way. So with that, the structural differences and how the profiles varied in size, as you can see, profile 0 encompassed 16% of the data set, profile 1 at 33%, and profile 2 was the biggest at 43% overall, and within the smallest was profile 3. And with it being said, this shows that the maternal population isn't a homogeneous structure, and it should, and with these distinct groupings, excuse me, guys. So now I'll be going into how each of these profiles have distinctive characteristics. And here I have a heat map of the Z-score standardized mean feature values. So with profile 0, as you can see, this was considered to be high reproductive, smoking, and infection risk. The mothers within this group had an average age of about 33 years. And as you can see in the first red grouping at the top, that is their extensive reproductive history, where they had the greatest number of prior live births, fetal loss, terminations, and cesarean deliveries. And then they also had the highest average BMI, which was 31.9. And then when it came to comorbidities, they did have a high prevalence of pre-pregnancy diabetes. And then in the second grouping of red, that is indicative of their smoking behavior. They had a very high prevalence of smoking before pregnancy and throughout all 3 trimesters as well. And then this group also had a low prevalence of prenatal engagement. They had the fewest average prenatal visits, and they had the latest initiation to actually start prenatal engagement, which most of them started into after the first trimester, into after their third month. And then in terms of infections, they did have the highest overall prevalence of syphilis, hepatitis B, and hepatitis C. And then in terms of the educational attainment, that was equivalent to a high school education. And then racially, this profile consisted of primarily white mothers, which was 44%. Hispanic mothers showed up as 23.8%. Black mothers were 22.4%. And the other racial groupings were very minimal in their representation. And then the next profile, profile one, these are the younger mothers where they had an average maternal age of 27 years. They had a very minimal prior obstetric history, which is very contrasting from profile one, profile zero, as you can see by the heat map where they have such cooler and bluer tones in their profile setup. And in addition to that, they also had a lower cardiometabolic risk in terms of diabetes and hypertension. They had very low prevalence of that as well, but there was elevated infections, especially gonorrhea and chlamydia for them. But they did have some prenatal care initiation, kind of similar to that of profile zero. And in terms of the racial makeup of this group, it was primarily Hispanic mothers, which was 64.2%. And then for profile two, this had the lowest observed risk overall. The average maternal age was 30 years, but it did have a low reproductive burden, similar to that of profile one. It did have the lowest overall BMI at 27.6, and they did have very minimal um, prevalence of any sexual infections, smoking, and all of the comorbidities in terms of diabetes and hypertension. The only thing that seems elevated here is not a true elevation. The one red bar is indicative of their education level, which they did have the highest educational attainment at having an equivalent to an associate's degree on average. And then with the last profile, profile three, that the mothers in this profile had the highest prevalence of comorbidities, so gestational diabetes, hypertension before and during pregnancy, and eclampsia as well. And these mothers also did have an increased number of average prenatal visits as well, which is probably indicative of their higher risk in terms of their comorbidities. They did have a high BMI, but overall, this was kind of like the distincting factor as into this subgrouping, especially considering that it was the lowest number at only 8% of the maternal population overall. And then when we look at the actual outcomes across each profile, given that the overall morbidity only encompassed 1.5% of the data sets, I converted the rates to show per 1,000 births just to have a more interpretable comparison. So with profile two, it demonstrates that it had the highest overall morbidity rate at 17.7 per 1,000 births, followed by profile three at 17.2. Then profile zero and one exhibited the lowest rates overall at 12.7 and 12.9. And excuse me. And even though the risk that was shown in the characterization doesn't necessarily reflect how they showed up here in a total morbidity, being that with profile two was characterized of having the lowest observed risk, it it kind of was contradictory with it having the highest overall morbidity overall. And then we have profile zero, which does have elevated rates of multiple of the morbidity outcomes, including maternal transfusion, ruptured uterus, unplanned hysterectomies, and ICU admission. But it did have the lowest rates of peritoneal laceration. And then with profile one, it demonstrated more moderate rates with a maternal transfusion rate of 5.2 occurrences per 1,000 births and peritoneal laceration at 6.1, and all the remaining morbidities were pretty relatively low, under 1%. And then in contrast, you have profile two, which had the highest rate of peritoneal laceration at 11.4 occurrences per 1,000 births, despite having the lowest overall rates for any of the other morbidities. And then altogether, the patterns that are shown within the profiles with the lower observed risks, such as 0 and 1, it doesn't necessarily correspond to the lower maternal morbidity overall rates, which indicates that the relationships between the risk factors and the outcomes are more complex than it shows on the surface. And then I'm going to the statistical modeling. I started with a chi-square test to assess whether the maternal morbidity outcomes varied significantly amongst the profile memberships. And across all the outcomes, the results indicated that they were all significantly associated with maternal morbidity, with all of the p-values being less than 0.001. And these findings just support that the differences amongst the morbidity rates of each outcome is not due to kind of like a random variation, but reflects actual meaningful differences across each profile. And then before performing the logistic regression, I did construct some composite risk domains by grouping any of the relative pre-delivery variables into broader categories, just because I want to avoid having to model all 38 individual variables separately for the logistic regression, which could really bring a lot of complexity and reduce their interpretability as well. And with each domain, it captures a different dimension of maternal risk. You have social demographic, which went over maternal ages for teenage pregnancy, maternal and at risk and advanced maternal age, lower educational attainment, and delayed prenatal care. And then you went into reproductive risk, which captured anybody who had any type of pre-cesarean, preterm births, termination, or fetal deaths, and those who had a short interpregnancy interval, which is considered being less than 18 months. The metabolic risk shows anybody who had a presence of any of the comorbidities of pregnancy, diabetes, not pregnancy, excuse me, hypertension and diabetes before and during pregnancy, and also anybody with a BMI greater than or equal to 30, which is considered obese. Then with smoking, that was anybody who had any incidents of smoking during or before pregnancy. Then infection risk was those who had any presence of any of the sexually related infections. And then when it came to the logistic regression, after creating those composite domains, I moved into kind of evaluating how all those different categories and the profiles were associated with maternal morbidity. And to do this with the logistic regression models, I did use profile 0 as the reference group since it did have the lowest overall rate of morbidity. And this forest plot will just display the estimated odd ratios where any value greater than 1 that's shown on the dotted line will indicate of increased odds of maternal morbidity. And when comparing the maternal profiles, profiles 2 and 3 did demonstrate higher odds of maternal morbidity relative to profile 0. And then with profile 1, there was some moderate increased odds. And this just shows that the findings are consistent with earlier, where it was observed differences in the overall morbidity rates, where profile 2 and 3 did exhibit the highest burden of outcomes overall. But the differences in the profiles aren't necessarily uniform either, which suggests that the profile memberships alone doesn't capture the variability in maternal risk. And then in contrast, when you're looking at the composite risk domains, there were some other patterns that emerged when you could see that reproductive and infection-related risk was consistently elevated in terms of odds relative to maternal morbidity, which shows that these domains may have a more direct relationship with the morbidity outcomes. And then metabolic risk did have some increased odds, even though they were less than smoking and infection. And then social demographic was showed a weaker correlation with maternal morbidity, being that it was less than 1.0. And then altogether, these results kind of show that the profile membership captures the underlying population structure and kind of show that the specific categories of risk, especially reproductive and infection-related factors, do play a more direct role in the maternal morbidity outcomes. And then I have a heat map going over the risk domain distribution across the profiles. Now, while logistic regression did kind of like quantify the strength of the relationships, I wanted to show how the risk was distributed amongst all of the actual outcomes. So based on this visual, social demographic risk was much higher across all of the outcomes, with approximately 0.77 for transfusion cases and 0.82 for both unplanned hysterectomy and ICU admission. And in similar fashion, metabolic risk also indicate was broadly represented across all of the outcomes rather than being specific to maybe one or two outcomes. And then reproductive risk had more outcome specific patterns where it had the highest rates for uterine rupture and hysterectomy. And then this kind of shows that it has more of a targeted pattern. And then with infection risk and smoking, those kind of had the lowest prevalence overall. But despite that, the earlier findings did show that it does have elevated odds in terms of its association with maternal morbidity. So that kind of suggests that even the less common factors can still have meaningful impacts. And then altogether, the patterns that are shown here on this heat map, it kind of shows how maternal morbidity is shaped by the different types of risk in varying ways, and how some domains may act broadly across the outcomes and others may show more targeted effects. And it kind of reinforces both the prevalence and the strength of the risk factors in considering how to fully understand morbidity across the entire population. And now we can get into the predictive modeling aspect. So the statistical analysis did help understand how the maternal risk was structured and how it relates to the outcomes. But now I wanted to evaluate how the profiles were useful for predicting the maternal morbidity. And to do this, the predictive models were developed using both the full cohort and profile stratified modeling. So with that, there was 20 total models that were constructed, and given the extreme class imbalance, there were some weighting techniques and threshold optimizations that were applied to try and improve the model performance. And then the composite over the overall morbidity composite variable was used as a target just to prevent any model instability from sparsity of the outcomes within the profile stratified models. And even though I did calculate multiple evaluation metrics, including accuracy, AUC, and PRAUC, I wanted to focus mainly on the F1 scores as a primary measure of the model's performance. So here you can see that, well, before I show you guys what F1, I just wanted to say that it does show the balance between precision and the recall. So it directly accounts for the true positives and the true positives in terms of the decision threshold for the model. So that's why I thought it was more appropriate to use. And then for the full cohort model performance, it was generally limited despite having the high accuracy that all them displayed, which showed that there were challenges in the models predicting such a rare outcome in a high imbalance environment. And then the other models, especially Profile Zero, did show some improvements with the F1 score of logistic regression and random forest doubling nearly from the full cohort to Profile Zero being stratified. And that also kind of follows suits with profile 3, 2, and 1. There were some improvements, but in terms of the overall predictive power, that was pretty limited. And I did notice that in the full cohort models, the ensemble methods, the gradient boosting methods, XGBoost and LightGBM did have the greatest performance in terms of F1 scores. But when it came to stratification, Random Forest did have the best scores overall in terms of stratification. And then while there was performance improvements throughout the stratification and not the overall predictive power, doesn't necessarily mean that excuse me, it kind of shows that the improvements in the model show that there is potential to help with predicting maternal morbidity by using the stratification, but in this case, it may just be better used in terms of just showing the heterogeneity of the population. And then in terms of future directions, Overall, these findings did highlight some of the key gaps that I mentioned previously in terms of how the maternal risk is traditionally understood and analyzed. So, first, with the traditional approaches, they did often rely on individual predictors, but this study did show how maternal risk is not only multidimensional, but it's also structured through the combination of interacting factors, especially that of social demographic risk, which was highly prevalent across the population, but it didn't necessarily correspond to higher morbidity outcomes overall. And then, secondly, um, you had the lack of subgroup discovery, meaning that maternal populations are frequently treated as homogeneous in nature, but the clustering analysis did reveal some distinct profiles with different combinations of risk factors and outcome patterns as well. And for instance, profile 2 and 3 did exhibit the highest overall morbidity rates, despite not uniformly kind of like showing the highest levels across all the risk domains. And this just shows that similar outcomes can arise from different underlying patterns that may not show up when you focus on primarily on outcome prediction, which gets into gap number 3, which was the weak linkage between the structure and the outcomes. The profiles did provide some meaningful structure, but the relationship between the risk and the outcomes was not exactly consistent. The profiles with the lower observed risk did consistently exhibit lower morbidity, indicating that there is a gap in how the given characteristics did translate into those outcomes as well. And then for the final gap was a disconnect between the analytical approaches that are used in current studies. So with my study, it did integrate multiple approaches between clustering, statistical analysis, and predictive modeling. And by combining all of them together, I was able to kind of have a better understanding of the structure of maternal risk in the US population and in terms to the relationship to how those outcomes are quantified, even though the predicted performance itself was pretty limited. But looking forward, the findings do suggest that improving maternal morbidity prediction will require more than the given pre-delivery characteristics that was given in the data set, but future work should include a continuation of this framework, but include more granular clinical data, longitudinal data that kind of looks over the risk over a period of time, geographic or environmental data to kind of show how risk may vary based on their location within the US, just to kind of better capture the multidimensional nature of maternal health overall and improve the comprehensive understanding of the risk across the maternal population. And that will be the conclusion of my study. And I would like to thank my advisor, Dr. Pinky, and all of those at Meharry SACS who have prepared me for the final capstone project over the past 2 years, and my classmates for their continued support and encouragement. Are there any questions?
Okay, thanks, Ariana.